Okay, let's just get the concept going. Okay, before we go on for Chinese New Year. Sorry, one more thing. Okay, homework, right? Okay, exercise 2.2, I decided to remove question 9 because I realized that it might be too challenging and not very meaningful. Okay, so exercise 2.2 don't have question 9. Okay, so no question 9. Right? Now, chapter 2.3, okay, on quadratic inequalities. Okay? Okay, focus. Right. So, in quadratic inequalities, the big thing that we want to learn, right, is how to solve an inequality like that. Okay, quadratic inequality. But the thing is that we must understand, okay, what does this actually mean? Okay? So, as an inequality or as an entire question, what we're trying to find is the range of values of x. Okay, we want to find range of values of x that satisfy range of values of x. Okay, that satisfy the inequality. Okay, but what does it mean by satisfy the inequality? Okay, so what it means to satisfy the inequality goes back to how do we read this inequality. Okay, it's trying to tell us that x squared minus 5x plus 4 is less than 0. Okay, so as a totality, this entire thing here, okay, we want the values of x that allows your entire expression to end up becoming less than 0. Okay, in other words, if I let this be y, I want my y values, okay, my y coordinates to be less than 0. Okay, so that is what inequality means. So, if I were to ask ourselves, how do we read or understand inequality? It means that okay, your y values is the values that comes out of your x squared minus 5x plus 4. Okay, so how we are going to solve this, okay, is that we're going to rely on our graph. Okay, we observe that our x squared minus 5x plus 4 can be factorized. Okay, it can be factorized into x minus 1 times x minus 4. Okay, having the factorized form as we learned, we know that it can help us draw our graph. Okay, the roots are 1 and 4 because when this is 0, x equals to 1. When this is 0, x equals to 4. That means that our graph looks something like that. Right? Okay, so back to our understanding of the inequality. We want y values to be less than 0. So on which part of this graph do your y values be less than 0? Okay, what points on this graph itself give us y values to be less than 0? They should be the points below your x-axis. Agree? Okay, all these points over here give rise to your y values to be less than 0 because your 0, your origin, is actually over here. Okay, so with the understanding that these are the points that are related to this inequality, that means that to find the range of values of x, it will be the corresponding x coordinates, and they all fall within this range over here. Okay? So therefore, our answer to this question will be values of x that are greater than 1, lesser than 4. Okay, so greater than 1 and lesser than 4. But actually we can write it in one single inequality in this manner. Okay, x is greater than 1, x is less than 4. Right? on this graph that allows us to have y values that are more than 0. Okay, so those are the points above the x-axis, and those are these points over here. Okay, right? And what are the corresponding x coordinates? We see that it is actually x values that are lesser than 1, and also x values that are greater than 4. Okay, but in this case, you cannot form a single inequality. Okay, you cannot say x less than 1, then after that, this doesn't make sense. Okay, individually it makes sense. X greater than 4, that's true. Okay, x less than 1, that's true. But then if you look at this itself, is 1 greater than 4? No, right? Okay, so you cannot write it this way. Okay, so if we wanted to answer the question that we had for our homework the other day, remember the one on the discriminant being more than or equals to 0? Where is that? Okay, that was in your exercise 1.2. Exercise 1.2, question 8a. Okay, so we were saying that our discriminant, which was 36 minus 4p squared, okay, because it touches the x-axis, so it should be more than or equals to 0. Then how do we actually solve this inequality or determine the range of values of x? Okay, we see that 36 minus 4p squared is as good as having, I shifted everything over to the other side, so I get 4p squared minus 36 less than or equals to 0. Why I do this is so that my coefficient of the p squared or the x squared in those cases, okay, is actually positive. So I always draw this shape itself. Okay, I always draw this shape. So in this particular case, I can actually factorize 4 out. Okay, I can also divide the 4 away. Right? If you don't enjoy reading an inequality like that, you can also write it this way. Okay, so we must always do our factorization. Right? That is because we need to know what are the x-intercepts. Okay, so for most of the time you can factorize. Right? Only in very, very rare times, okay, whereby the equation or the expression cannot be factorized, then what should we do to find the x-intercepts? We use the formula. Okay, so most of the time we can factorize. In cases where we cannot, then we have to use our formula, our quadratic formula, this one, okay, to determine what are the roots. Right? So from here, we know that it can be factorized, right? It gives us p minus 3, p plus 3, less than or equals to 0. So how does the graph actually look like? Okay, it will be a U-shaped curve, and then after that, having negative 3 here and 3 over here. And we're looking at less than or equals to 0, so these are the points below the x-axis, and therefore your range of values of x is over here. Okay, and hence our answer will be between negative 3 and 3. Okay. So basically you can remember it as, if your answer is in between, okay, the numbers, you can write it as a single inequality, continuous inequality like that. Okay, if it is separated out, okay, on both ends of your quadratic curve, then it needs to be two separate inequalities. Okay, so this is actually the answer for question 18. Right? Okay, I'll leave this concept with us, okay, because that's the end of our lesson. Right, when we come back after Chinese New Year, okay, we will practice some more about this concept. Okay.